Most.
Hey, good morning, everybody. Thank you for taking the time to join. We hope that you guys get a nice kind of overview of some really good products and some applications that could hopefully save you guys a little bit of headache, save you some time here and there. But again, I'll introduce myself. I'm Tyler. I am the local account manager here in Kansas City that supports your guys' firm there. And I'm going to turn it over to Bruce, who is our water wastewater division manager for Vector. And then after him, we're going to have Alan Vance, who is the industry manager for Indris and Hauser. And then Butch Daly will be speaking as well, and he is the analytical business development manager. So again, thank you for your time, and I'll hand it over to Bruce here.
Good morning. Thank you, Tyler. I want to thank everybody for spending an hour of your time with us today. At the end of this hour, we will make sure to get you a PDH credit for this 1 hour of presentation. So I'm not going to talk much more. I want to hand this over to the experts, Alan and Butch. You guys go ahead and take it away.
Thank you, Bruce. My name is Alan Vance, and I'm the industry marketing manager for all of water wastewater at Indris and Hauser for the United States. I'm coming to you live from my home in Tampa, Florida today. Unfortunately, with the COVID situation, travel has been very difficult lately. So I do appreciate everyone from Burns and Mac taking the time to attend this presentation. I know we did one a month or two ago on flow, which was very well received, I think, by Burns and Mac. So we look forward to doing this one today on analytical. So I'm going to do a brief introduction, and then I'm going to flip it over to Butch. And then I'll come back on at the end and just do kind of a summary overview. So we'll get started. And as Nikki and Tyler mentioned, if you have questions, just type them in the chat box, and we'll address those at the end of the presentation. Butch, is the slide move? There we go. Anyhow, what we're going to talk to you today about, and Butch is going to do the bulk of this, but we're going to cover our complete liquid analysis portfolio, which is a very, very strong portfolio for us in both drinking water, which we'll talk about today, and also wastewater as well. And this platform really has come a long way over the last 6 to 10 years, let's say. And I think you'll see when Butch dives into some of our sensor technology, you'll see some of the big advantages that we have in this market where our customers really find a benefit and a value to using our particular electronics and sensors. What you see here is our common platform. That's our CM44X field mount transmitter, the blue box in the center. And then we're going to talk about a mixture of different sensors that can connect up into our transmitter. And boy, if you have seen our product line, 8, 10 years ago, we used to have 6 or 7 different transmitters, and we only had certain sensors that could go into certain transmitters. And I'll tell you, it was a nightmare for us to produce. It was a nightmare for customers to figure out, and it was certainly a nightmare for engineers to specify. But we have now streamlined all that. It makes it very, very easy for when you guys are working with a customer and developing specs for analytical equipment. Next, Bruce.
I'm pushing. It's just slow to respond. Here you go.
Yep. Yeah. And one thing I do want to point out before I flip it to Bruce is that one of the big things with Indris and Hauser is we actually manufacture in the large market. We have complete manufacturing facilities throughout Europe. We have manufacturing facilities in India, China. We are ramping up some manufacturing in South America, but we have complete U.S. manufacturing for not only our analytical equipment, which comes out of Anaheim, California, but also at our factory in Greenwood, Indiana, which is just south of Indianapolis. We build all our flow meters there, our level and pressure devices, temperature devices, et cetera. So a lot of people think with the name Indris and Hauser, we're a German or Swiss company, which we are, but we've made some serious investments in the last 8 to 10 years to the tune of close to $200 million into our U.S. facilities. And we're quite proud of that. So everything that Butch talks about today, a lot of it will come out of our factory in Anaheim, California. So with that, I'm going to flip it over to Bruce. He's going to dive into some of these technologies, and I will see you at the end of the presentation. Thank you.
Good morning. Everybody can hear me okay? I apologize for the glare on my glasses, but if I'm going to do this against my computer screen, you're going to have to put up with it. All right, so initially we're going to talk about pH electrodes and the Anderson-Hauser suite of electrode configurations. So we have a typical pH glass electrode, we have an ORP electrode, and then we have the pH ISFET electrode, which are 3 different types of electrochemical sensors that we manufacture. The first we're going to talk about is a traditional pH electrode that looks like this. Everybody can see my picture, I hope. I'm showing you guys the standard pH electrode with a glass bulb and an electrochemical reference. It's got a porous reference membrane, and that is what everybody describes as a typical pH electrode. And that electrode works just kind of like a battery. So you see a picture of a battery here, then you take the battery out of the way and plug in a glass bulb electrode on one side and a reference lead on the other side, which could actually just be open to atmosphere. As long as it's conductive to the outside of the glass bulb, it will close the circuit. So then, in order to protect that reference electrode, we surround it with an electrolyte, which is mostly potassium chloride, silver chloride, so that it's conductive and can come in contact with the outside of that glass bulb through these porous junctions. So then you have a pH sensitive glass bulb that has an internal that is buffered with a silver chloride element on the inside, and then it's buffered to a 7 pH on the inside. So it is a stable 7 pH inside that glass bulb. And so this, you have your traditional 2 electrode system. So what happens here is how this sensor works is on the inside of that glass bulb, you've got a solution that's 7 pH. And if it's 7 pH on the other side of that glass bulb where the glass electrode has formed this gel layer, you see this very thin gel layer. You can't see it with your eye in a physical situation, but it's generated every time you put a pH electrode in an aqueous solution. So what happens there is if it's 7 pH on the outside and 7 pH on the inside, there's no potential difference. And so the probe generates 0 millivolts. But if, for instance, it's an acid environment and it's less than 7 pH, what's going to happen is all of the hydrogen ions are going to migrate into that gel layer, which is going to generate a positive voltage trying to reach equilibrium. And so that positive voltage is indicative of the actual pH. So the pH signal that is generated it's 59.16 millivolts per pH unit. So at 0, you're at 7 pH. At 6, you're at positive 59.16 millivolts. And at 8, you're at negative 59.16 millivolts. So if you do the math quickly, your full scale pH range in a traditional pH electrode is plus or minus less than half a volt. So you've got a very finite range to make this measurement in. And so that's just giving you an idea of how it's done. So that's a typical traditional pH electrode. Now, what we do different at Anderson-Hauser is we also offer what is called an ion selective field effect transistor electrode. What it does is it takes away the glass. It's no longer as fragile. It's much more robust. It'll fit into some more difficult service without being breakable. It's technician proof. You can drop it. You can hit it on your hands. You're not going to break it. And it's just as reactive to the pH changes as a traditional electrode. How it works, however, is it still has the same electrochemical reference internal with the silver chloride and the potassium chloride conducting fluid, and then it has a little porous membrane. But then it also has a silicon substrate that has a charge to it, a negative charge to it that attracts the hydrogen ions. And so that's how it makes that measurement. So that's the difference between a traditional electrode and then the ion selective that has the gate insulator with the semiconductor phase here. It's got a ceramic bond across there, flat sealants, temperature sensor, a diaphragm, just your reference junction parts here, and an elastic fitting and a polyether ketone construction of the body. So it's much more robust. You can put in a lot of services. You can get away from the breakage if you have abrasive or other surfaces that are rough on a typical glass electrode. And so this gives you a quick view of the differences. Okay. Then the next electrochemical measurement that we make is ORP. ORP stands for oxidation reduction potential. And this measurement's very close in theory to a pH measurement. But the pH is actually measuring the activity of the hydrogen and hydroxyl ions. ORP is measuring the activity of electrons. Both methods deliver a millivolt signal, but they're using different scales, pH for pH measurement and a millivolt scale for the ORP. One unique thing about oxidation reduction potential sensors is they're not measuring oxidation or reduction. They are measuring oxidation and reduction at the same time. So whenever you put this probe in service, it is going to have elements in that stream that will oxidize and some that will reduce, and both of which will generate millivolts, some positive, some negative, and then the sum total is the measurement that we're making. And we refer to that, and it's used often in some people use it as a free chlorine measurement, sometimes in a cooling tower application, but there are other areas where you might look at ORP measurements. But it uses a noble metal, typically platinum or gold, sometimes silver, but typically platinum or gold. And it has a standard, again, reference electrode light with silver chloride and potassium chloride. And it's measuring through this circuit the oxidation and reduction of this noble metal, whether it's platinum or gold. And that's the typical method for oxidation reduction potential measurement. Okay, we're going to slip into conductivity. At Anderson Hauser, we have 3 different types of conductivity sensors. A typical conventional contacting conductivity, which is used for very low conductivity solutions and mid-range conductivity solutions. And basically this type of measurement it's a function of physical geometry of the cells. So if you look at these cells, they have a large surface area here, but a very slight distance between the outside and inside surface area in the 0.01 cell constant. So that's designed to measure very ultra pure water down to less than half a micromole. Whereas then you go to the next cell constant, which is a 0.1, you'll see there's now more distance between that cell and the outside cell. And that's measuring the resistance between those 2 points and generating a resistance measurement. Conductivity is the inverse of resistivity, and that's how this measurement is made. So typically it's a function of the geometry of the surface and the distance between the 2 cells in the design. So, and basically these will come in a cell constant that comes from the factory, like a 0.01 or a 0.1 or actually a 1 constant. And these are designed for specific ranges, and I'll get into what those ranges are a little later in this presentation. So they come in a number of different configurations, some for higher temperatures and pressures, some for, these are boiler water applications, then some for boiler water on the other end when your makeup water, when you're getting down into the 0 to 20 microsiemens, very, very low, ultra pure water. So you have that capability. We also offer a non-contacting conductivity sensor. This conductivity sensor is often referred to as a toroidal sensor, non-contacting sensor, or an inductive conductivity sensor. And it functions a little bit like a magnetic flow meter. You have two coils that are opposed and they generate a voltage. And then as the stream flows through those two coils, an induced voltage is indicative of what the actual conductive strength of that solution is. And so that's how a toroidal conductivity sensor works. These come in both polyether, ether ketone, and then a Teflon coated solution for other acid, for high acid concentrations, that if you want to make a concentration measurement with your conductivity. And this slide will show you the different ranges and what you might be measuring with these cells. So if you look down there, you have a cell constant of 0.1, that's your ultra pure water sensor. And then you get, as you move away from that 0.1 to a 1 cell constant, you can see that you're getting into pure water, potable water, wastewater, and then mixed chemicals. And in the mixed chemical range, conductivity can also be converted into a percent concentration. So if you're doing a mixed bed or an anion cation bed, and you need to regenerate a resin, you have that capability of utilizing conductivity for your percent concentration of acid and caustic measurements. Okay, turbidity. Anderson-Hauser again has a full line of turbidity sensors. A typical application for a turbidity sensor might be a membrane filtration, where you get your raw water coming in from wherever it's coming from. That's likely to be a much higher turbidity than after you've gone through your primary filtration, right? So you have it on the front end and the back end of your primary filtration. You'll have turbidity sensors. There are two types of turbidity sensors that we provide at Anderson-Hauser. For small particles and low turbidity, and turbidity is basically measuring suspended solids in a solution. But when you say suspended solids, everyone thinks that it has to be a solid. It could be a bubble, it could be entrained gas, it could be anything that is going to change the reflectivity of the light. So our light source is going to be shining through the process, and then we will use a nephelometric detector at a 90-degree scatter from our light source to make a measurement when there's small particles or low turbidity, and that'll give us a range here as shows in this scale to make that nephelometric range analysis. That's our typical standard turbidity measurement. And then we have a standard sensor that we recommend for that. That's our CUS52D. Then when you get into an area where there are significantly more particles and or bubbles or a more homogeneous sample that you're trying to measure turbidity in, we introduce a second sensor. The second sensor is called a backward scattering sensor. It's at 135 degrees from the initial light source. So what we're doing now is we're measuring both the nephelometric at 90 degrees and then the back scattering at 135 degrees. What that allows us to do is compensate for where the turbidity gets out and comes over the top of that peak. At that point, we don't know which side of the peak we're on until we go back and look at the backscatter sensor, and it gives us a much more indicative measurement point for turbidity. So when we have a much, what's the word, a much more higher turbidity solution, that's when we'll use the CUS51D with the backscatter sensor. It's all digital fixed cable. IR light source with pulsed LED, sapphire windows. It's got 6 sapphire windows. And we also offer some cleaning devices, some ultrasonics and things like that for this sensor. Then we have the low turbidity sensor that goes down from 0 to 400 FNU or TU. You will oftentimes hear turbidity units referred to as milligrams per liter, NTUs, FTUs, TUs. All of them mean the same thing. They all are scaled the same. They all mean the same. It just, they use a different standard to make the calibration, and it makes no difference as to what you refer to it. Nephlurimetric turbidity units is the typical standard. Okay, chlorine, moving right along. We've got 2 types of chlorine sensors for total and free chlorine at Anderson-Hauser. We have an amperometric total chlorine measurement that uses a 2-electrode sensor and a membrane to make this measurement. What's happening is basically the chlorine combines with the iodide on the internal mediator, creating iodine. And when it creates the iodine, itself is reduced at the cathode back to iodide. And this is generating a voltage that's indicative of the total chlorine. Then we also have a standard basic disinfection sensor, which is just a buffered electrolyte system. The upside to this is that we offer it in a solution that comes in a package. You know, it comes with our transmitter. It comes with this flow block, the CCA 250 flow block, that also will house a pH ORP combination probe and a conductivity sensor, so that you can now make 4 measurement points from one little flow box. You can get the chlorine, the pH, the ORP, and the conductivity, all from the CCA 250M flow block. And we package that nicely. We put it in here where you have the standard flow block. You notice how we kind of trapped it so it always has a nice wet sample in there. We've got some valves and gauges on it, and then the standard transmitter. So that's our chlorine solution. Before I move on to the next thing, I overlooked a few other sensors that we do have in our portfolio. We have DO sensors, but typically they're not used in water treatment. They're more wastewater, so I just kind of bypassed that today. And then I'm moving on to what we call our colorimetric analyzers. Also a Liquiline system, the CA80 product, measures ammonia, phosphoric, I'll remember them here this way, orthophosphates, aluminum, nitrate, chromates, iron, and hardness. All of these colorimetric analyzers are available. We also have power analyzers for silica and sodium, all on this similar platform, utilizing the Liquiline platform. A typical colorimetric sensor determines the concentration of a colored compound in solution. So what's happening is in this analyzer, it's going to take a reference measurement of your process, then it's going to add a reagent to that process, and it's going to note and it's going to accurately measure the difference between the different components as they're dyed in your sample. So it's got a lot of moving parts. It works real well though in the way that we've done it in the Liquiline platform, so that we can see some actual absorption of the light as it goes through the colored components in the sample dyed system. So the reference measurement is always taken so that we can compensate for any interference that's caused by color and or turbidity of the process. Okay. And you know, I got through that a lot faster than we thought I would. So key product overview that I want to talk about before I hand this back off to Alan is our Liquiline process. If you notice this HMI, the standard HMI here, you'll see it here, and you'll also see it over there in the CA80. The HMI is the same, and that's part and parcel to our program. All of our analyzers and sensors utilize the same HMI so that your technicians and engineers don't have to learn more than one protocol. And also, in this one transmitter, the 44X, as we call it, because it's available in a 442 with 2 channels, a 444 with 4 channels, and a 448 with 8 channels. Any of our digital sensor that is just plugged into that transmitter is immediately identified as a pH, a conductivity, a DO, a chlorine, a turbidity, whatever it is, and then it'll bring up a screen ranged for that typical measurement and that analysis. So at that point, I am going to give it back to Alan to speak to our digital sensor technology and our Liquiline platform. Thanks for your attention.
Thank you, Butch. I'm back here. Hopefully, we've got about 6 or 8 slides here, and then we'll be wrapping up. So what I wanted to do was just talk to you a little bit about our digital platform. Those of you that have been around a while and can go back years, I mean, a lot of the instrumentation, sensors, et cetera, used to be analog, and we still make some analog type devices, but I'm happy to report that all of our sensors in our liquid analytical platform are now digital. So it has been a great improvement to the customers, the end user municipalities that use these type of sensors. And of course, we sell the same equipment in the industrial accounts as well. So food and beverage, life sciences, oil and gas, chemical, et cetera. So what we did years ago was we said, hey, we need a digital platform. So that platform we call MemoSense, MEMOSENS. And that really refers to the digital technology between our sensor and our transmitter. So if you look at the split screen here on the left, you'll see sensors that have kind of a blue head to it. These are what we call a quick disconnect or an inductive coupling. So we basically have a sensor, and then we have a matching coupling that has the cable coming out of it that goes up to our transmitter. So all these sensors that carry this blue head can be quickly changed in the field by just a quick disconnect. You can plug in a new sensor, tighten up the disconnect, and put it right back in the soup. So typically the ones with the blue connector on that are low power sensors because we use an inductive coupling, which I'll explain here in a few other slides. And it has to be, we can't send a great amount of power across that inductive coupling. So only our low powered sensors are like this. If you look at the right side of the screen here, you'll see that we don't have those blue inductive couplings, but just a cable coming right straight out the back of our sensor. These sensors are our high-powered sensor, like our DO or dissolved oxygen, or the fourth one over, which is our ISE Max. And these sensors require more power, so they're a direct cable wire from our sensor to our transmitter. However, nonetheless, no matter whether you get the ones on the left or one on the right, they are digital. So as Butch just said, as soon as you connect the sensor up to channel 1, it will know that it's communicating to a pH sensor. If you took that pH sensor off tomorrow and connected up a DO sensor, it would say, hey, I'm now communicating to a DO sensor. So our ability over the years to streamline this product line and have simplified has really helped out our end users and engineers from a specifying standpoint as well. So as Butch mentioned, that's our typical field mounted transmitter. I will mention we don't have a picture of it, but we also have a DIN rail mount enclosure as well that can fit in the back of panels, and it has an optional display. They both function the same. So this particular box can go from 1 to 8 channels. So if you have a customer that's got, say, just a pH and a turbidity and he needs a 2-channel unit, we can do that. If you're measuring 4 points in that area, we can set it up as a 4-point or an 8-point. The nice thing I want to mention too is that, let's say if you start out with 4 points and you wanted to bring 2 more points into that transmitter, All you would have to do would be to buy that input card that you see on the right there, and then a sensor with the cable and connect up, and automatically you go from a 4-channel, say, to a 6-channel. So we've also given the customers great flexibility in if they want to upgrade these in the field. But as far as the transmitter box goes, we have all the outputs. We are pretty much agnostic output. We can do 4 to 20 HART, and then we have all the digital communications like Profibus, Foundation Field Bus, Modbus. But we also have Ethernet IP, which is really great digital communication, ties in quite nicely with our alliance partner Rockwell. So what that means is if you have this transmitter tied into a Rockwell ControlLogix or a Rockwell Plant PAX system, our engineering department works with Rockwell's engineering department prior to us releasing a product, and that product then will have all the add-on profiles, add-on instructions, faceplates, so that when you connect it to a Rockwell controller, it knows it's talking to an Endress+Hauser pH probe or a DO probe. So we have that built in right into our transmitter, and you will see a lot of customers when they upgrade their plants, they are moving more and more to digital communications. So we have Ethernet IP in our Analytical and our Flow products, and it works out quite nicely. As Butch mentioned, display interface. With our CM44 platform, we have the field transmitters. We have it in our refrigerated or automatic sampler, and we also have the same electronics in our colorimetric analyzer. So what does that mean when you guys are talking to a customer and specifying a project, right? Whether or not they have our analyzer or field mount transmitters or samplers, the basic configuration is the same because it is our CM44X platform. So the technicians at the plant, they get very familiar with the programming menu, the parameters you put in, et cetera. Even though it's different, so to speak, between a pH and a DO, all the menu structure is the same, and it has the same look and feel across all those different products that I mentioned, or different transmitters. So let's talk a little bit about MemoSense, what exactly that is. As you can see, these are, we're going to get back to those ones I described to you with that blue inductive head. So really what it is we've made sensors, and inside that sensor, we embed a chip, and that chip contains all the calibration and all the information associated with that particular sensor. So these low impedance sensors, then when you connect it to the holder with the cable, as you see in this picture here, all that information from that sensor is automatically transferred through that inductive coupling, which then goes up to our transmitter. So again, I try and always put this in terms of what does this mean for the end users, because that's really what we're striving for, is how do we make it easy for these end users to use our product. Because the sensor contains a calibration chip, you could actually receive this unit from Endress+Hauser pre-calibrated and plug it in, and it'll automatically send that information up to the transmitter, and the transmitter will say, hey, I have a calibrated new pH sensor. Let's say it's running for 6 months and you have to clean it and recalibrate it, right? You could do that in the lab with a different sensor. You could walk it out to the plant, engage that twist lock, put the new sensor in, and again, as soon as you put that new calibrated sensor in, it sends that information right up to the transmitter. So you don't have to carry out buffer solutions and everything out to the actual physical probe. If you live in a very cold area or rainy area, like I do down here, lightning, you know, it makes it very, very easy to make sure you can calibrate these in the lab or in the instrument shop, take it out and make a quick swap. So with that inductive coupling, if you look at the picture here, you'll see, well, one of the big features of this is that you'll see no exposed copper. It's strictly like a hard type PDF connection. So one of the big failure points in the older pH probes and other probes, and some that our competitors still make, is that exposed copper begins to corrode and fail, right? With our inductive coupling, basically it's almost like a like one of your electric toothbrushes. You kind of put it in that holder and then you pull it out and that thing works, right? So we're basically charging that through this inductive coupling, if you will. So we are able to, because it's low powered and it's digital, we were able to give you much longer cable lengths, up to 100 meters or 300 feet. So with the old analog sensors, you are limited in how far you can have the sensor from the transmitter. So again, with our platform and this MemoSense technology, greater flexibility for the end user.
Okay. Let me step in here real quick, Alan, because as I put these presentations together, I realized I left out what I felt is a pretty important part of our product solution. Part of our MemoSense technology is we also have a solution called MemoBase. And MemoBase is a little black box that'll convert your PC into a laboratory pH analyzer. And so if you bring those probes back into your instrument shop or laboratory to do those calibrations, you can calibrate them on your PC, and it will store the data into a spreadsheet format for you. So if you have an EPA required calibration or something like that, then all you'll have to do now is download out of that software, say, here, this is everything we've calibrated, every pH probe every day. There you go. And you don't have to, it takes the requirement of storing that data, typing that data. You do the calibration on your laptop, on your notebook, whatever it is, through that little black box, and MemoBase will store that calibration history. You can use it as a preventative maintenance tool. It's just a significant advantage to anyone who's ever had to deal with a whole bunch of pH electrodes or conductivity electrodes or DO electrodes all out in the field that are, it'll help you identify your bad actors. It'll help you, do all kinds of good things that make maintenance such a better deal. But that's it. I think that does it for us and our technical portion of this presentation. We're going to, I think, go to the Vector team. Is that correct? Or are we going to go to questions, Nikki?
Thank you, Butch and Alan. Yes, we will move into the question and answer session of our webinar now. And we do have a few questions that have come in. So let's see, the first one is asking, are your sensors for pH, chlorine, and I apologize, I can't say this word.
Turbidity.
Yes, I apologize. EPA approved for reporting, or would they be for process control only?
The answer is 2 out of.
Go ahead, Butch.
Yeah, the pH and conductivity, no doubt. The turbidity for ultra pure drinking water, we do not have that EPA sensor today.
Yes, our R&D is working on an EPA 180.1 approved turbidity sensor for final drinking water. As Butch just mentioned, we do not have that today. So, but certainly in the process world and process control, they're used extensively.
Okay, great. Next question. Can a sensor with the inductive head be completely submerged?
Yeah, I can take that one. We do show the picture that you see with water, so I don't want to mislead you guys at all. The sensor is not rated for IP68, so we do not recommend that the sensor be fully submerged. If you fully submerge a sensor, what happens typically is at the back where the cable comes into that holder, eventually you will have water ingress come in there, and obviously you're going to probably short the sensor. So as far as rain, as far as splashing it, as far as cleaning it off under a faucet, none of that is a problem, but you don't want to submerge this below water level permanently because it's not IP68.
Yeah, temporary submersion is
Correct.
viable. I mean, again, it's not the connector that's going to fail. It's the glue that holds it to the probe.
Yep.
So, okay.
Okay, great. Next question. Are all of the instruments you discussed today NSF 61?
Oh boy, you guys, you must have a bug in my office here. You're asking such good questions. NSF 61. A lot of E&H products have NSF 61 approval. For example, our magnetic flow meters have NSF 61. Our gauge pressure and differential pressure transmitters have NSF 61. And the requirement per NSF is from basically at the drinking water facility, from the filters on through the plant and out through the distribution system. So currently, we do not have NSF 61 approval on our analytical sensors. Now, there are reasons why, because a lot of these are monitored off a slipstream or bypass line, which is then dumped, so it doesn't go back into the process. However, we do see from a marketing standpoint that requirement changing. So we are looking to get NSF 61 approval for many of our key sensors for drinking water, like turbidity would be a big one. So when we get the EPA 180.1 turbidity, it will also have NSF approval. But we do not have it on our sensors, and I believe the majority of our competitors don't have it either on all of their sensors as well.
Right. The ISFET might be a viable candidate for it, but any of the glass sensors won't be it.
Right.
Okay, great. Next question. With your MemoSense analytical sensors, why do some have the plug in inductive head and others have the fixed cable?
Yeah. I think I might have touched on that on the slide, but basically it comes down to power. All the ones that have the blue inductive coupling with the twist lock, they are what we considered our low powered sensors. Sensors that require more power to, and typically there are optical sensors, if you will. We cannot send enough power across that inductive coupling to power those. So those are direct cable, if you will. But again, they are still digital, they are still MemoSense, and they will be auto-recognized by our transmitter.
Okay, great. And just a reminder for the audience, if you do have a question, go ahead and type it in the question box to the right on your control panel, and we'll get to it here. Next question. Does Vector offer any type of on-site service?
I'll field that question, Nikki. Great question. Yes, we have a full service staff. We have 15 plus technicians that can go on site and take care of making sure that you have a successful startup. And if a customer should want to contract our services to do it quarterly, twice a year, once a year, we have that available to support whatever the needs the customers may have. Great question. Thank you.
May I add something as well?
Please do,
Sure.
Tyler.
On that, so to add to the commissioning and startup, whenever we come out and do that, it takes the factory warranty from 1 year to 5 years, which is a pretty big value adder. Just whenever you're starting up and getting these projects running on time, and also giving that a little bit of confidence after you leave that the customer is going to be able to have that warranty. Then we also do we do verifications and on-site calibrations with a couple of the municipalities around the Kansas City area. We were just actually in the city of Eudora last week, and it's not only Indris and Hauser that we do. So it can be other manufacturers that are on site, and we have the capability to give you the paperwork and everything you need to be compliant.
Okay, great. Next question. For the analyzers that use a tap line off the main process line, example, the turbidity, do you have an option for integrated solenoid so flow can be stopped by SCADA when that filter piece or a piece of the plant is not in use?
I can answer that question. The CM44X transmitter has internal relays so that you could, with a connection to a SCADA system, you could have the SCADA system say, hey, close the relay that could shut off a valve. But as far as the solenoid to be part of the solution, that would be external to what we would provide. Unless you wanted us to provide it on a panel, then we can integrate it in.
Yeah, Bruce, I was going to maybe build upon that. At E&H, we have standard products that we offer. And as you can see, the one slide that Butch put up showed a free chlorine panel. And that panel, customers can order, or you could specify just that panel. Beyond that, we have a solutions group. And then many of our reps have the flexibility to put some solution type panels together as well. So typically, like I say, as Bruce said, we wouldn't supply the solenoid valve. You just use a relay contact coming out of our device. But that's something that when you meet with Bruce and Tyler, you guys can discuss, and we can certainly quote an entire package for a customer.
Okay, great. Next question. So does Anderson Hauser work with the engineers on specifications?
Oh, yes, all the time, 24/7, 365, just like the process runs. Yes, at E&H, I mean, we sell through full line representatives like Vector across the 50 states. So in each of those regions, our reps, obviously we work with the end users, we work with OEMs, we work with system integrators, and then of course we work with the engineers that are designing everything for the municipalities. So Tyler and Bruce and sometimes an E&H representative will visit. We can do lunch and learns. We can update you on current product offerings. We can do sizing, for example, on flow meters, etc. We can supply you guys with CAD drawings. We can help with takeoff. And we just have a whole bunch of stuff that we can make your life easier, right down to the actual CSI bid specification pre-written on our website. So we try and make it easy to work with us from a design standpoint, because I've been doing this long enough. And the more questions we ask and get done up front, the less problems you have when that thing's being installed in the field. So there's a lot to instrumentation nowadays as far as, hey, how are you going to mount it? And then what do you want to do with the signal, et cetera. So we come in and we ask all those questions and work with you guys, and it makes everything a lot easier on the back end.
Okay, great. So does Vector also offer any type of training for this technology?
Great question. Yes, we are certified to do training. We offer 1-day, 2-day, and 5-day training classes. We will be kicking off our new building here in the next couple of months, where we're going to have a complete process training unit. It's going to be 3 levels high. It's going to offer multiple tanks, multiple streams, so that we can give you classroom training and then hands-on training, so that when you walk away, you'll be certified to go take care of your equipment.
Fabulous. Okay, let's see. We have another question here that came in. So you talked about wet panels a bit. Could you elaborate on that product line? Many times our contractors or integrators use a poly board to mount instruments to. Does Anderson Hauser have that as a product?
So not as a standard solution, but as we all discussed at one point in this question and answer, Vector and/or E&H does integration, and integration by design is whatever the customer's requirement is. If it is a plastic panel board, we'll build it that way. So we have that capability.
Hey, Butch, maybe go back slides. I think you have a slide of the free chlorine panel, and I'd like to highlight. Yeah, we recognized a number of years ago that we needed to, again, simplify stuff for our customers. So this is just an example. Now, this is a standard product that we do have. It's our free chlorine panel, and we also have it for total chlorine. So we have various options of this. You can get it with 2-channel, 4-channel, et cetera, but we will supply this entire assembly as is. We have Anderson-Hauser part numbers for that, so that the customer can take that, hang it right on his in his chlorine room or wherever, and make his connections and go. Bruce or Butch was talking a little bit about our ability to maybe make different panels, and we can do that as well. For example, if you wanted a larger panel with multiple transmitters on there and different sensors, we can do that as well as a solution, and provide you guys a drawing of that, et cetera. So we're moving in the direction of more of the solution type panels.
Let me kind of add a little bit something to this panel, just so everybody kind of sees. You can see the sample comes in, goes through our sample flow block, and then the middle leg there comes down actually as a DPD test port. So
Right.
We have included in the fabrication of this a way to draw a sample and be able to test the sample for the DPD, so it can be part of the calibration process. So that has been taken into account in the building of this panel.
Thank you, Bruce.
Okay, and it looks like that concludes our question and answer session. So thank you for joining us. We hope that this was a worthwhile experience for you and you learned a little bit from our experts here. I'll turn it back over for final comments. Alan, we'll start with you.
Yes, thank you, Nikki. Well, on behalf of everyone at Anderson-Hauser, I wanted to thank you guys, Burns and Mac, for taking out the time. It's we've been doing a lot of these lately. It's certainly something that we're more used to visiting in person and having these meetings, but with the situation as it is, we're doing them via the digital or virtual aspect of it. So, but I wanted to leave with you that Anderson-Hauser is definitely a leader in the water wastewater market. We understand it's a tough market as far as products, product features, options, specifications, pricing, bidding, et cetera. But we are coming out with some great products for this market. As I mentioned, we're building a lot of these right here in the United States. So we're not going anywhere. As a matter of fact, I like it tough. The tougher for me, the better. So we can be successful in this water wastewater market. And I think we work closely with key engineering firms. And again, in my mind, it's what does the end user end up with? And that's really what would make Burns and Mac shine, the system integrator shine, and Anderson-Hauser shine, if everything gets in that plant and is working properly. So our goal is to work with you guys and ensure that that happens. So thank you for your time. Butch?
Yeah, again, just thanks for your time, and we look forward to coming and maybe doing this in person in a post-COVID world. So thanks again for your time, and hopefully we offered some value. Thank you.
I want to step in next here. I want to thank you as well for your time. This was the first of 2 parts. This was the water presentation. In the not too distant future, we'll follow back with a wastewater presentation where some of the same equipment will be again rediscussed, but we will be adding additional equipment that is very effective and very pointed at the wastewater industry. So with that, I again want to say thank you for your time. And Tyler, I'm hand the baton back over to you.
All right, thank you. Well, I'll be redundant and thank you guys again. Your time is precious, and we do appreciate you taking the time to join us today. Just to kind of add what Bruce said, we're looking forward to doing the next one more focused on the wastewater side, but we'll make sure and kind of follow up and provide, you know, where some of these questions came in. If there's any documentation or anything we can provide on that, I'll make sure and get all the lists and information from Nikki on our side, and then coordinate with Angie on your side and get you all the information that you guys had questions on. But I think that's it. So we'll talk again soon.
Have a great rest of the day.
Thank you, everybody.